Hi, this is a brief consideration of the energy consumption of water supply in an arid country where reuse becomes an option. In an arid climate with no natural aquifer, the only options for water supply are the sea and sewage. Well, clearly most people prefer this source rather than this one, but well, sometimes there's no option. The processes appropriate to treating these waters can be categorized as biological, clarification, disinfection and desalination. And the individual processes we're going to consider are the conventional activated sludge process, or CAS, the membrane bioreactor, ultrafiltration or microfiltration, classical media filtration followed by disinfection by UV irradiation, and then desalination by reverse osmosis. RO will always be preferred as the desalination option unless there's bucket loads of free or low-cost thermal energy available. Now, if we take the seawater source first, this has to be filtered either by membrane or media filtration before being desalinated. The permeate from the RO is then drinkable, but it's normally rehardened to add alkalinity and stabilize the pH. Sewage is classically treated by the CAS process. Prior to desalination, it would, like seawater, need to be filtered by either of these two options before going to the RO stage. The other option is to use an MBR instead of CAS. This will produce a clarified water which then no longer needs to be filtered. So the filtration disinfection step is unnecessary in this case. And once again, the RO permeate will be drinkable but will require the same post-treatment as for the seawater feed. Now let's look at the energy consumption of these individual processes. And firstly, the seawater treatment scheme. The UF, MF and media filtration disinfection steps are comparable energetically. The RO stage, though, has a very high energy consumption, and this is because the osmotic pressure of the seawater is directly proportional to the salinity. It works out at somewhere between 25 and 30 bar of pressure. Add all the hydraulic losses and resistances and you're up above 50 bar, and pumping up to these pressures uses a lot of energy, more than 3.5 kilowatt hours per meter cubed. Biological treatment of the sewage using the CAS process uses about 0.35 kilowatt hours per meter cubed of energy, and the downstream clarification and disinfection incurs about the same energy consumption as for seawater. But because the sewage normally has less than 1/10 of the salt concentration of seawater, the RO process only consumes around about 1 kilowatt hour per meter cubed. The MBR is higher in energy than CAS, but as I said before, obviates the clarification disinfection step. Now that means that regardless of the route taken, seawater desalination incurs around about 4 kilowatt hours per meter cubed of energy, whereas reusing sewage incurs less than half of this. So even though it seems unpalatable, it's more energetically sustainable to get drinking water from a sewage source than from the sea. And that's it. Thanks very much for listening.